Welcome everyone. I hope I don't need to use the microphone, but it's on, and I think it's been used. Anyway, I'm Thomas, and I will be doing a tutorial about building a walking skeleton. So I will discuss a little bit what it is, some history, and then there will be some live coding where I will start with an empty editor and end up with a working or functional web application. It won't be nice, it won't be great in many senses, but it will work. It will have a user interface, we will have a database connected to it, and we will be able to enhance it afterwards. This tutorial is long, so long that I will not take a break between the two sessions. If you feel that is a problem for you, then feel free to use the lower 2 feet if you need to. So now you've been warned, and let's get started. So, what is a walking skeleton then? So I'm going to discuss a little bit about why, history, and then how, what, and finally an example. So let's start with why should we use a walking skeleton? Well, the biggest reason, as I can see it, is risk reduction. If you start building something and you build it perfect in one end or in one part, and then you actually don't really know if it will work in the rest of the system or not. So that is a risk. And since we're cowards, or at least we should be, then we want to reduce the risk as much as possible. So risk reduction is perhaps the most important reason why we should use something called a walking skeleton. What we will be able to do is validate the technology. It's quite often that we build new things that hasn't been done before. Well, that's why we call it development. So it's often hasn't been done before. It's quite common that we use technology that we're not that familiar with. We haven't used this framework before, something like that. So validating technology is very, very important. And what we do is we make sure that we connect the important parts really, really early. So we don't postpone things that are risky. We try to deal with the risks immediately, or at least as early as possible, because that will give us the most time to fix the problems when we find them, because we don't know what we will find. This hasn't been done before. That's why, again, it's development. Your average or your normal application consists of these 3 parts. In some sense, we almost always have some kind of user interface. We almost always have something in the middle that perhaps do the business logic or whatever, do something. And almost always we have some kind of persistence layer or some kind of persistence. When we do something, we want to be able to keep it. It's common that we use a database. You can use a file system, you can use whatever, but persistence. We always have some kind of persistence at the bottom. So to validate the toolchain, we want so we want to validate the toolchain, and we want to make sure that we have a good development process as early as possible. That's really, really important. And we also want to be able to enable us, or be able to do small deliveries, because small deliveries are easier to build, easier to test, and easier to revert if they are bad. Small things are key, always. If we do something small, then we can do it pretty fast. That means that we will get early feedback. That's good. We will know in a day or 2 if the decisions we took were good or bad. So that's nice. And remember, the prototype is worth more than 1,000 words. Much more, actually. Okay, so a little bit about the history. This is obviously not a new concept. Alistair Cockburn claims that he came up with the idea around 94, so that's a little bit more than 20 years ago. He didn't give the name until a couple of years later. And this is his definition. So he says that a walking skeleton is a tiny implementation of the system that performs a small end-to-end function. It need not use the final architecture, and that's kind of important, but it should link together the main architectural components, the user interface, the middleware, and the persistence layer. The architecture and the functionality can then evolve in parallel. So if we find that we did something that wasn't great, we perhaps used the wrong database or persistence layer, then we can change that. But we won't know it until we've tried. This is also the theme for something called Tracer Bullet from the Programmatic Programmer. So Dave Thomas and Andy Hunt, 99. How many has read that book? Okay. The rest of you, you have a great book to read. It's actually fantastic. Tom and Mary and Tom Poppendick, they're talking about spanning the application. That's pretty much the same thing. You build something, I mean, see it as a tent perhaps. It's not great. It's not a fully functional building, but it will cover you from shield you from rain perhaps. So it's perhaps good enough at the moment. And this is also one of the themes in one of the best books I've ever read, Growing Object Oriented Software Guided by Tests. How many has read that book? How many? One. The same guy. You read the Programmatic Programmer as well? Yeah, okay. So we've got one reader here. That's nice. Steve Freeman, Nat Pryce, wrote a fantastic book, 2009. So if you're interested in test-driven development for real, this is the book to read. It's not an easy book. It takes time, a lot of time, but it's really worth it. So Growing Object-Oriented Software Guided by Tests, that's something I can recommend. Okay, so how do we do this then? Well, let's try to wire up some kind of architecture. As I said, there is a user interface, there will be some kind of server, and there will be a database. And I want to try to create a production-like environment. I mean, that's not that easy on this small machine, but I will do my best. So what should I build then? On a perfect tutorial, I would give you a lot of options, but I have to prepare, so I've done a lot of choices. So I have done some choices regarding architecture. So I will use a framework that is freely available, and it's a Java framework called Dropwizard in this case. The development style, well, I like test-driven development, and I like to do unit testing compared to what Simon said yesterday, although we do agree on a lot of things. And yeah, component testing, unit testing, I don't know, how large is a unit? We have to decide on the development environment and how we should test stuff. So these are choices that I have to do. And now, if no one has any questions, let's dig into some implementation details. So I'm going to use version control, obviously. I'm going to make sure that I use something that is freely available, so I use Git. This means that I will be able to push this code to GitHub afterwards. So you don't have to do take a lot of notes if you don't want to. You can read all the code afterwards. Same goes with these slides. I will place them on SlideShare afterwards. I need to create some kind of build script. And in this case, I'm going to use Gradle. How many in here are using Gradle? Few. How many in here are using Maven? More. And Ant? A few. Okay. And the rest you don't use. Okay, you use other tools. Right. Gradle is, how should I describe Gradle? It's kind of like Ant, and it's kind of like Maven. It's very. You're free to do whatever you want. You write your build scripts in Groovy, so you have access to a programming language, which you don't in Ant. But you can do whatever you want. It solves some of the dependency problems that Maven also solves. So it's kind of a mix of both. And to be honest, I really enjoy it. It's unfortunately a bit slow, but well, I can take that. Ant is really fast, Maven is so-and-so, Gradle is, to be honest, a bit slow. Gradle has a great feature called wrapper. That means that I'm able to define in my build script which version it should use, and then all I have to do is generate this wrapper. I will get a jar file and run in Gradle using shell script that they provide. I will be able to run it anywhere where I haven't even installed it, because it will be downloaded and installed for you, which is fantastic. This means that anyone can use the same, everyone will use the same version. So it's self-contained. We will use the same version everywhere. You can't say that, oh, I used the wrong version of Gradle, because you don't. And in this case, I will be using the latest version, which is 2.4, released like a couple of weeks ago, something. I will use JUnit for testing, as a testing framework. And I will use JUnit for both a test acceptance, integration, and unit testing. I will also set up a few code quality tools, which is really, really easy to do. I will show you how. So we'll use Jacuco for test coverage and PMD for static analysis. And I don't always agree with the rules in PMD, but there's a way to modify them, which I will not show today. I'm going to build a web application, and I'm going to connect all the pieces using something called Dropwizard. Anyone heard about Dropwizard before? Okay, so that's, oh, well, that's good. So one person. So this is new for most of you guys. How can I describe Dropwizard then? Well, it's open source to start with, which is nice because then it's accessible for everyone. It's quite community driven. There is no company behind it, as far as I know at least. It's very opinionated. You either follow how they think they should do things, or you choose another framework. So you don't have a lot of choices. And that is, in many cases, a good thing, because I don't need a lot of choices sometimes, because I don't know too much about the subject. I need firm rules, and this will give me quite a narrow corridor of things to choose from, which in this case is nice, because there are good things that they bundle. And the result is supposed to be an executable jar. So I will build a jar file that I will run from java-jar and the jar name, and then 2 commands on top of that one. I need a database, and I couldn't afford an Oracle, so I choose for Derby, which in this case, it doesn't really matter. The good thing with Derby is that it's embeddable, it's Java only, and it handles, Java only. So I will be able to fire up a database on my computer without any installation, which in this case is great because I don't have time for any installation stuff. Databases, they have schemas, that is the tables in them, and things like that, indexes. They need to involve, so I'm going to use something called Flyway to do that. Anyone heard about Flyway? Yeah, a few guys. Liquid Base, anyone? Few? Okay. So Liquid Base, Flyway, they all solve the same problem, and you can always build your own, it's very easy. What they do is they look at the database on application start and check which version is it. And if it's not the correct version, then it will do whatever it takes to make it to transform it to the correct version. That is, run a set of SQL scripts if you need it, or in Flyway's case, you can run Java code if you need to do something that is hard to do in SQL. So it's a way to make sure that the database is always in the state that the application expects it to be. Very, very handy, and in this case, very, very easy to implement as well. Okay, enough chatting. Time for some live coding. And before I do that, I'm going to grab a glass of water. Okay. So I said I'm going to use Gradle, and Gradle, you create your build script in something called build.gradle. So I'm going to create such a file. And there we go. I don't do more than that, because this is enough for my favorite editor to start. So I'm going to use IDEA. And you can use any version if you want. There, I'm going to use the ultimate version because I paid for it. If you need, use the what do you call that? Community version. Thank you. It's great. I use that at work for bad reasons. The guys I work for, they don't think it's a good idea to buy tooling. So I'm using the community version there. And this is it. All I need to do is touch that file and I will be able to open it in IDEA. And before I did this, I created or I initiated a Git repository in that directory. And it's all I already have at least one commit on GitHub because I updated the README file. So what should I start with? I'm going to start with creating git ignore, because that's good. Is anyone familiar with Git? A few? Okay, that's good. Git has a really nice feature. You can write an ignore file and tell it which files to just ignore. And in this case, I'm really not interested in the project files for IDEA, so I'm going to skip those. I'm not really interested in files that Gradle downloads itself, and I'm going to skip more IDEA project files, something like that. Okay, so let's commit this and say that we ignore the project files, like that. All right, we need some content in this file because currently it's empty. So let me see. I wonder if I just have experienced a big problem. Let me check. I created a lot of live templates yesterday, and did I screw up or not? I did screw up, but only in my notes. Oh, there we go. Right, so I've been able to create a live template, so I don't have to type a lot, which is nice. I had hoped it would work more seamlessly than it did. This is a build Gradle file. I'm applying a couple of plugins, that is Java, Jakuku, and PMD. The thing with Gradle is that you can build anything. You don't have to build a Java project with it. So I have to apply a specific plugin for getting access to tooling that will compile Java programs, for example. By specifying Jakuku and PMD, I'm able to use those plugins for test coverage and static analysis. I want to define a version of this project, so I do that. And I want to set up a set of dependencies. And I'm just going to start with the the simplest one that I always want and use. That is JUnit in this case. Since Gradle doesn't really know anything, you have to specify everything it should use. I have to specify which repository I should use. So unlike Maven, where you use Maven Central, or what they now call the central repository, I have to specify which repository to use. And I could use Maven Central, or I could use Maven Local, or I could use something else. In this case, I'm using JCenter, which is pretty much the same thing as the central repository. I also define that I want to use some specific PMD rules. PMD is tooling for static analysis, so it will tell you if you have unused variables, perhaps a condition without brackets, stuff like that. Some of these rules are okay. I don't agree on all of them, so then I try to skip them. So you have to choose which rules to use, and I'm going to use 2 here, not more. For the simple reason I don't have time to fix all the errors I would create otherwise, and so I don't even want to see them. As easy as that. The last thing is a wrapper. I specify that I want to use the Gradle version 2.4, and this means that I will be able to create this Gradle wrapper with that specific version, and everyone will be able to use the very same version when they build their project. Okay? So let me start by actually using the wrapper, Gradle, and then I'm going to call wrapper. Is it possible to read in the back, or should I increase the font? It's okay? Okay, good. Right. What happened? Build successful. That's nice. Well, the thing that actually did happen is that... Oh, is it possible to read the code? I didn't get a good answer on that one, so I'll change my setting a little bit. Sorry for not thinking about that. There we go. This is hopefully easy to read. I got 5 new files. Build Gradle has not been committed yet. This Gradle wrapper jar should be checked in, because that is the jar file that will actually perform the downloading of Gradle if you don't have it. There's some properties defined, so we know which version to use and where to find it. And then there's 2 shell scripts, or 1 shell script and 1 failure. That is a shell script for Linux-based computers and a batch script for Windows computers. And maybe I shouldn't call Windows a failure, should I? I don't know. Maybe I shouldn't. Anyhow, this is what I need to do to be able to use Gradle wrapper. So let me do that. Let me restart my editor and actually use the Gradle wrapper. And in this case, use default wrapper like that. And let's delete and re-import this stuff. Alright, so this is the way to open up a Gradle project using IntelliJ IDEA. Very, very simple. And which version are we actually running if we running this then? Let's see, Gradle wrapper, and let's call version. And we can see somewhere that it's Gradle 2.4 here. Okay, so what can we do here then? Well, the plugins gave us a lot of new tasks that we didn't have access to previously. But since none of you, not any of you knows this, you didn't even know that we didn't have access to them. But we have now access to something that will build a lot of stuff. Java doc, testing, and we have a Jakuko test report. This one will create an HTML report that would show you the test coverage. And as with any number, this is dangerous territory. Because if they are misused, you will start misbehaving. I've seen projects, I've been actually working on projects, where people have thought test coverage is great. Let's create a lot of test coverage. And in order to do that, at least one guy, he just ignored asserting things. So if you want to create great test coverage, write unit tests, but don't verify anything, because then they might break. He understood that I was upset when I found that. I was very upset. And he was kind of angry when I deleted that code. Oh. Right, so we're using Gradle 2.4. So what did I do? Well, I committed a Java project. No, I did not commit. I prepared. And 2 warnings. I'm going to ignore them at the moment. And I'm going to continue with verifying the unit testing framework. There we go. And for some reason, which I really don't understand, I have to refresh the Gradle project on and off. There's no such thing as automate the imports and stuff if I do change the Gradle projects at the moment. There seems to be some kind of bug in IDEA. Anyhow, let's create a source folder. Gradle uses the same structure as Maven, that is source, main, and test. So let's start with the test because that's most interesting. And Java. And I will also create main and Java. And the package where stuff can live. Like that. And what do I do to assert that the testing framework actually works? How do you get anything? How do you test anything the first time? The hello world. So I'm going to create a hello world test, which is very low level, but it will give me a chance to verify that the testing framework actually works. And yes, I want to add this to Git. Right. Okay. And we need to import unit test, that's good. Public void and you may notice that I don't use camel casing. Why? Well, camel casing is that's the way to do things in Java, but it gets hard to read. And I'd like to write an entire sentence sometimes in my test cases. So therefore, I very often, or actually nowadays very seldom, use camel casing and very often use snake casing when I write tests. When I write the production code, I do follow the Java paradigm, but this gives me an opportunity to write a sentence that is easy to read than something that looks like this. It's okay to read this one because it's quite short, but suppose that we have, I don't know, 20 words, it gets hard. So therefore I prefer to do it like this in test cases. And PMD gets very, very upset about that. But there are ways to go around that. Okay, so what do I expect? I expect something. Let me say that I expect hello Bucharest, like that. Almost, yes. Where's my error? I do think I have a deficiency in the fact that I'm having a hard time to see misspellings. And therefore it's great to have spell checker in your editor, at least for me. Right, so that's what I expect. I need some kind of production class that actually can do this. And I'm going to create something, hello world, sorry, new. Almost like that. No, I don't want some JVM hotspot hello world. I want to roll my own, so let me create that. Okay, there we go. And then, very easy, something. We expect something, and I usually call that actual. And if I specify that should be a string, then it gets a lot easier when I tell this one to create method. Something like that. And now I should see if I can spell Bucharest. Yeah, I think I made it. Fantastic. Right, and then we want to do asserts because test without asserts, that's bad. So actual is the expected, like that. Okay. So let's create this method and see that it works. Yes. Let's call this one name. Let's throw a not implemented exception because it's not implemented yet. And then let's do a static method import assert that JUnit is good. And Hamcrest matcher, that's good. All right, I should now be able to run this test. And I get the option to run it either as a Gradle test or JUnit test. JUnit is faster, so I will use JUnit. Oh, it failed. Bummer. But that tells me that I have work to do, and of course I'm not surprised because I made it myself. But I always do this when I create a new method, because otherwise I might forget to use it. And if I forget to use it and still has this one throwing not implement exception, no one can use it by mistake. It will break. And I will get warnings. I'm importing stuff that I shouldn't import. So doing this is a habit that I think is quite good actually. Let's just return the name, and it compiles. It's actually even green. This little dot here is, or box here is green. Oh, that was Swedish, sorry. Running it. Failed. But that's good, because now I can fix it very easy. And I'm not sure if you actually work like this on your day-to-day basis. I do, and it's great fun. So let's do hello, and let's add an exclamation mark, like that. And we have just proved that the testing framework actually works. This is very nice, because now we can move on. But before I do that, I'm going to commit this, and I'm going to say something something clever. Yeah. So I just verify that we can run the tests. If you think this is too low level for you, you don't have to be here. The low 2 feet is still valid. Right, so we're in a sense dressed up, but we have no place to go. So what should we do? Well, let's go back to the presentation and see what I'm actually aiming for to do. Which behavior am I expecting? Well, I'm expecting some user, a happy user in this case, because this user will get the pizza. And the user interface that looks something like this. It's very, very simple. You have to give them your phone number, and then you just type the kind of pizza you want and submit it. The response you will get is supposed to be something like this. We just received your order. Nothing more and nothing less. And you can't choose, well, I mean, it's a free text field. You can choose any pizza you want. The pizza delivery, the pizza parlor may not have that pizza, but they can probably create it. Pizzas are done on delivery, on request. So this is the behavior that I'm looking for. And since I prefer working outside in and test driven, I'm going to start with an acceptance test. So how am I supposed to do that? Well, I need to start with a dependency to a testing framework. And, oh, how unfortunate. I did not prepare a snippet for this one. So I have to spell to org selenium hq dot selenium minus Java, and I want to use the version 2.45, like that. I also would like to separate the acceptance test from the unit tests. So in order to do that, I'm going to add a specific source set. Acceptance test source set. There we go. This means that I can specify where these acceptance tests should live, and I don't have to mix them with the unit tests. So it's a way of organizing my code a little bit. But in order to do that, I also need to add a task that actually is able to run these tests. So let me do that, like that. So this specifies that in the folder source acceptance test Java, that's where my Java code will live. And if I have any resources, they're supposed to live in source acceptance test resources. And I want to combine the class path from main and test. And it should, the runtime class path should be the combination of the output from that one, and this output. And I also want to make sure that I have a task that is called acceptance test that actually is able to run whatever I put in this acceptance test Java folder. And in order to group it in a nice way, I add it to the group verification. I add a small description, and I define where the test class is and what the class path should be, and that's it. So doing this, I'm able to create a new folder here that should be called acceptance test. And if that one has a Java directory, it will be in the class path when I do a Gradle refresh. And anyone familiar here with with IDEA will notice that this one has slightly different color than this one. This means that this is a source folder for test classes. All right, and let me add some code here. So let's start with the package. Think code. Yeah, and a class that I call pizza order acceptance test. A very long name, but it's kind of descriptive, so let's go with it at the moment. Right, so what will I do here? Well, I'm gonna create a test, obviously, and I want to set up some stuff. So I need, in this case, I'm going to use Selenium, which is a browser automation framework. So I will run a browser. In this case, I will run Firefox, and I will verify that the application actually works. And I will want to do that before, and then I want to shut it down after. Okay. I also want to test. And I choose the wrong one. So in this case, I want to go to the order form, fill it out, and then submit an order, and assert that I got the right things back. This one requires some methods. That is, go to the order form, fill out the order form, submit the order, and get the order confirmation. And anyone familiar with Selenium should now say, you should use a page object. Yes, I know. But that would be too complicated in this case. No, it shouldn't be. But in order to keep it as simple as possible, I'm going to avoid that today. So I need to do some imports, and I need to specify a field. Field browser, it should not be a Firefox driver, it should be a web driver, like that. And sorry? But I just did. I'm doing something wrong here. So the demon just bit me. Let's do like that. Okay, so now I know what mistake I did. I added. No, I didn't. No, you're correct. I should have added some dependencies before. My bad. It's not that easy. So, no, I did add the dependency. Did I refresh? I can't remember. I did. Yeah, exactly. Okay. So in a perfect world this would work. I don't know why it doesn't at the moment, and I will find out in a few seconds, I hope.
Can you look in the structure to see?
There is nothing here. What?
Have you tried turning it off and on again?
No, I haven't. And maybe I should. I'll do that. It sometimes works. No.
Maybe version 246 is not in the repo.
Did I specify 246? 245. Okay. That's unfortunate. To be honest, I don't know what the problem is, and I don't know how to solve it at the moment. It should just work. So I'm going to do a Gradle build while I'm thinking. And if anyone has any great ideas, please let me know.
I have a question.
You have a question? Yes, go ahead.
I'm a front-end engineer, and the idea is, isn't it quite a bit early for user acceptance testing, because you really don't know who is going to handle, for example, if there are a team of 2 people, you are actually querying some divs and other elements which you don't really know how to display them and so on.
That's kind of correct. And that is the reason why it's hard to do to test drive user interface. But you do know that we want to add a field, and we know that we want to know who placed the order. So I think that we should be able to do something, and we will probably have to redo this more than once. And I see that I'm probably misspelled something. So I will go to this one, and I will find the correct spelling of selenium. Like that, 245, and I will try to grab the correct spelling here. The version number. There we go. Oh. So the lesson learned from this is you shouldn't try to type anything in front of an audience. Right, so I was able to refresh this one, and with some luck, yes, now we're talking. But I don't want a Firefox driver, I want a web driver here, like that. And yes, I want to import that one. And I want to create a field for this wait object, like that, so we can wait for an object to show up. I want to assert that this actually works. Like that. And we want to search for some fields using some locators. And that's actually it. And it's a little bit narrow here, but let's start from the beginning, now that everything works, or seems to work at least. So I'm setting up a new Firefox every time I run a test. I make sure that we will wait for objects to show up 20 seconds and then fail. When a test is done, we should quit the browser. The test is that we should go to an order form, fill it out, submit it, and then try to get the order confirmation. As easy as that. And then verify that the actual pizza is the one that was confirmed. So a nice pizza with lots of cheese. I like cheese. So how do I do this? Go to order form. Well, I go to localhost. I try to locate an element called phone number. I try to fill out a form. That is, I try to locate the phone number element again and send keys to it, that is type, in a field. And then I try to find an element called pizza description and type in that field. Finally, I'm trying to find the form, and it turns out that if I find any element inside of a form and then do submit on it, then Selenium will be able to submit that specific form. So it's okay to find just the pizza description in this case. This means that I will be moved to another page, and I will try to find an item that is called order item, and I will wait a while before it show up. Or if it is slow, then I will wait a short period of time. And then when I find it, I will return the text that I find in the item called order item. And I'm searching using ID. So all these tags has to have these IDs. And that's why I think that it's possible to do this early. Because I know which kind of elements I'm actually looking for. And I also require that the guys who will implement the user interface, which probably is not me, actually has these tags as well. Okay. Let's see, does this work? Anyone think this will work? I don't. But let's try to run it anyway. As Firefox is started, oh, I couldn't connect. That's not very strange. There's nothing to connect to. The application doesn't even exist yet. Right, but I'm going to commit this anyway, because this is a step forward. And what I just did was added acceptance tests, like that. And now I'm going to move on and actually implement the application, or at least parts of it. So the first thing I need to do is make sure that I can build an executable jar from Gradle. This means that I will use something called the shadow jar. And it should not be this one, sorry. It should be shadow jar plugin, like that. And if I apply a plugin like this, then Gradle will search for it, and with this specific version in a Gradle specific repository, which is a very nice way to get hold of plugins. In order to use this, I need to create a task that actually, or I need to specify some details around the shadow jar. Like this. And this means that when I run the task shadow jar, I will create an executable jar file, which has a main class, which is this main class. And that's it. So now I will be able to write java-jar and specify the jar file. And it will work if this class exists. But it doesn't yet, so I'll have to implement it. Alright, so let's create a main class here. And the content of this should be something like this. I extend an application, and then I configure it, and I enable to get the name from it, and initialize some stuff. So this is all Dropwizard stuff. And it uses something called configuration. I don't have something called configuration yet, so I'm going to create that. And I'm going to create that in an infrastructure package. And I'm going to leave it empty for the moment. Okay, is this enough for this one to be quiet? No, it's not. Because I have forgotten to add some stuff in the build Gradle that I should do. I need some dependencies here. And I need something that I call Dropwizard dependencies, like this. So I'm adding core JDBI and assets from Dropwizard and a template framework called Mustache. They all are all of the same version, so I specify that the Dropwizard version should be 0.8.1. And I also want to use some testing stuff that they provide. So given this, I should now be able to import some stuff in main, and with some luck it might even be happy. It's not, because I'm still lacking some stuff. So I'm going to add an health check as well. Dropwizard will nag you if you don't have a health check. And what this one will do is that it will be able to check resources if they are available, if they're happy or not. And in this case, I'm just gonna do the simplest possible and and add some health check content like that. I should have done some stuff with the configuration as well, or I think so at least. Yeah, because this one needs to extend the Dropwizard configuration class, so we're able to add functionality here later. Right. We're still lacking things. Some kind of order form resource, so I'm missing a package that should contain the business logic or the actual use case that I will implement. And I'm a very big fan of keeping things that belong together. Well, that's not a really good way of expressing myself. I think that it's nice to have all resources that is used for a specific use case together. So I prefer to have database connectivity, whatever, in the same package. I don't prefer layers where all the DAOs in one layer is in one package, all the SQL stuff in one package, because that makes it hard to navigate my code. So I'm going to create a package that is called order.pizza that will contain all the logic that I will use to order a pizza. And the first thing I will do is add an order form resource. No, it's not the first thing I will start with. I will start with a test. And it should live in the order pizza package. And I will call it order pizza test. And it is supposed to do some unit testing on the classes that will actually make up the logic here. So the content on this one should be order pizza test, something like this. I'm lacking some classes here, but I'm supposed to get some kind of resource, and this is something that will listen to a call post, and it could be a REST service. In this case, it would just be someone listening to a form. And it should receive some data, and I will then return something to forward people to confirm a view that actually confirms the order. and then I will try to get the order item, verify that it's the same thing that I expected. So let's start with the receive order resource. No, let's start with a Java class that is the first point that we will come to, order form resource. So this is something that will listen to for posts, and it will just listen on slash. So whenever we go to localhost port 8080 slash, we will end up calling this one. This one will forward us to something that is called an order view. And an order view looks like this. This one will return an order view, and it will use a form, in this case mustache template, that will be transformed into HTML, and that's it. And then we will have to have something listening for the order that was actually sent. So I'm going to create order, receive order resource, like that. And this one listens for post on this path. So we can either have a user interface or we could have a REST service. Doesn't really matter. And this one will forward us to something that will confirm the order. So let's create a class confirm view with the content confirm view. My bad. So this one will create an HTML page from a template called confirm order mustache. It will add the order item to it, and this one will be able to I will be able to display this fairly easy, at least. And I think that this might actually compile now, if I'm lucky. It did not. Or? It did not, because I always forget that I'm using Java 8, and this one thinks I should use Java 6, which is strange. Let's do it again. Compiled, completed successfully. So this means that we can ship it, doesn't it? Or actually it doesn't. Because we haven't tested it and we are lacking some resources. We don't have the templates, and there's some more stuff that we actually need before we can get this web application up and running. So, such as the HTML files. So let's add those files, and let's create a directory called resources, like that, and then add some stuff here. For some reason, I'm not really sure why, the guys behind Dropwizard thinks it's really nice to have some kind of banner that you show when you start the application, and they will nag you if you don't. So I will add a banner, which is just ASCII art, saying, in this case, walking skeleton. Why? They think it's fun. I think it's kind of nice, so it's okay. And we should have fun as well, shouldn't we? I'm going to add a style sheet. And since I don't know what to call it, I'm going to call it main CSS. And the content should be something like this. Style sheet. and I assume that everyone in the room is better than me on CSS. So this was what I was able to create. It's a walking skeleton. We're supposed to have it up and running and then extend it. Okay, so what next? Yes, we need to create the templates as well. And they should live in the same packages as the views that actually calls them, if I don't specify it specifically in the view. So I'm going to put them in SE-think code like this, and I'm going to create a file that is called, sorry, my bad, it should obviously be order pizza as well. There we go. And I should have a file that is called order form mustache in this case. That will be used when we try to order a pizza. And what should the content be then? Order form mustache. It should be something like this. So this is basically a simple HTML. The only specific thing here is nothing, to be honest. It's in the confirm view that we will have some mustache specific stuff. But this is a place where you could add stuff from the backend easily when it's created. Okay, so we need to be able to confirm this order as well. So let's create a confirm order. And the content here should be confirm order like this. So we have a headline, you ordered something, and then we have an order item paragraph with an ID tag, so we should be able to find it. There is a method called getOrderItem in the view, and that one, the result from that method will be displayed here. So this is a way to communicate with the backend. It works. Is it good? I don't know. Now what? Yes, we need to configure some settings to be able to start this application as well. So I'm going to create two configuration files. One that is supposed to be for production, and I'm going to call that one configuration. YAML. Did I misspell something? Yes. Like that, is that better? Yeah, thank you. And what should the content be? Well, it should be something like this. So this is a YAML file that specifies properties that this application actually wants, such as which port should it listen to, where should the admin interface be. Out of the box, I will get some administrative stuff as well available on this port. How should we log? I will be able to add more properties here, but this is an alternative to having a property file. It works quite nice. It's fairly okay organized. I want another configuration for the testing, and at the moment they will actually be similar, but they will change later. And how much time do I have left?
Half an hour.
Half an hour. Okay, we might make it. I might make it. What should the content be? Well, this content should be test stuff in the test configuration, which currently is the same as now. Okay, so let's see if this compiles. It should, but let's see that it actually does. All right, pizza order acceptance test will be the default test that I will run if I try to run something. So let me do that. I'll fire up a Firefox and it still fails. Okay. Why? Well, the reason is that I haven't started the application before I try to do the acceptance tests. So let me try to do that. Let me create a rule. This one will fire up the application before the tests are actually executed, and it will use the test configuration available in the class path. So with some luck this would actually work. And as you can see, the ASCII art showed up. And we had a web application that was started and we verified it. You want to see it again? I want to see it again. And I was wondering, yes, no. So it will be quite fast. And there's Firefox. There's application, and I filled out a nice pizza with lots of cheese, and I actually got that back. That's not too bad. It's 11:05, we started an hour and 15 minutes ago. We don't have any persistence yet. I will try to add that, and hope that I will make it on time. But before I do that, this is a good point where I can actually save the work I've been doing. So what did I do? Well, I implemented a web app. That's what I did. I will probably have a lot of warnings and stuff. Yeah.
I have a question. Perhaps I
Sorry?
missed, I have a question.
Yes?
Perhaps I missed it. Can you go to the line in the business logic where you actually send the description and confirmation receives it? So I would like to see what you actually tested.
So, would you want to see the business logic or the test?
Where, no, the business logic.
Okay, the business logic. Let's go there.
So where you send the string and then the string.
Right. So let's. You know what? I'm gonna show you another thing and then go back here, because this is a good place to go back to the presentation and look at the expected flow, because that's what you're asking for. And the application flow is something like this. We have a happy user. This one will submit the get to slash through this form. He doesn't even know it, but that's what he will actually do. It will end up on the order form resource that will display the order view, that will use the order form mustache, and then you should fill it out and post it, that is, press the submit button. It will end up in the receive order resource, that is, listen to slash order. It's supposed to persist the order, but it doesn't at the moment, but it's supposed to do that. And it is also supposed to confirm send the confirm view and actually confirm the order, and using the confirm order mustache. And that part is working. So what we're lacking is the persistence part. So now let's go back to the code and look at what you were thinking of. So where should I start? I will start here. So this is where someone accesses this application from the beginning. The result is that this order view is returned. This order view is using the order form, which is just plain HTML, nothing special. When someone submits this order form, they will end up in receive order resource, which looks like this. It listens at slash order for post. And it reads stuff from the input form. So we're able to get phone number, and we're able to get pizza description. And then we forward to the confirm view.
You don't get any warning for not using the phone number?
No, it's a skeleton. It doesn't really. It's not that foolproof. So if you add crap here, something will break. And then, as I said, we forward to the confirm view, and the confirm view looks like this. It gets an order item as an argument, and it calls the confirm order mustache, and here we set the order item as an instance variable, and there's a method get order item. And the framework knows that whenever I find something like this, I should look for a method called get order, which is the someone that I lost. There, which is this method, and that is the way to communicate. 10 minutes left. Oh, someone had half an hour. That was really bad, because in 10 minutes I don't have time to add the persistence layer.
There are still 10 minutes of break.
Sorry?
There are still 10 minutes of break.
You got solutions for everything. What I'll do is I'll wrap up the presentation, and then I'll continue with adding the persistence, and we'll see where we end up. That's hopefully a reasonable mix, or not mix, but what do you call that? I don't know. Something reasonable. So, what did happen? Well, the thing that happened was that I used Git for version control. You saw that. I also used Gradle with the wrapper, so I know which version we will use when we build this. For testing, I created an acceptance test. You haven't seen me creating an integration test. That's next. An integration test where I verify that the persistence actually works. So that would be faster than firing up a Firefox. It will do a lot of verification, and it will verify that we're actually able to talk to the database. And I also had a unit test that actually uses these resources. So I know that the inner logic is actually working. And I also know that the outer logic is working. Unfortunately, we don't have any persistence yet. And I've been using Dropwizard, which is an opinionated framework. It creates an executable jar, which you haven't been able to see. And that I have time to create. So I'm going to do that. So I'm going to create something that I call Gradle. Clean is nice. Build is nice. And then I'm going to do shadow jar. And just for the fun of it, let's do the acceptance test as well. So if I were able to type this properly, we should build the system, and we should not have a build fail. PMD. The thing is that if I don't specify that the rules can be ignored, just warn, then PMD will actually fail the build. The fastest solution is to disable it. And I don't recommend you to do this, but I have 10 minutes and I want to show you the end as well. And now we're testing, we're building a shadow jar. That is, we're packaging everything needed in the same jar file. which will be a quite large jar file, and then we'll be able to run it anywhere. We don't have to download anything, do any installation or anything like that. And there was Firefox, and it took 27 seconds to build everything. Let's see if we can run it. Okay, so I have two jar files here, and I'm going to use the one called minus all. And then I have to say that you should start in the server. Doesn't really look very nice, this ASCII art on this small screen. Actually quite bad. It took 2 seconds to start this application. It should be available on localhost. It is. Nice. So I should be able to order a pizza, and since we don't have any checks, I can write whatever I want here. Okay, nice. Pizza. And then submit that. And it behaves. We already knew this, but we hadn't seen it in slow motion. I also specified that we are listening on port 8081. And what can we find if we look there? We can find some metrics about this application. How long time has it been running? How many threads are being used? Stuff like that. We can ping this application. It will respond with pong. Why? It's a great way to know that it lives. Nothing more. We can see how many threads are running, and we can run health check. This one will say that it's healthy because I hard-coded that. But we're able to check if resources are available or not. And this is out of the box, which is kind of nice.
This is provided by what? By Dropwizard?
Yes, this is provided by Dropwizard. The only thing I did, which you saw, was creating the health check. I also specified that we should listen on port 8081, and that was all I did. And then we got this out of the box, which is kind of nice. Is it a deal breaker? Not sure, but it's nice. Okay, so Dropwizard. Opinionated, we create an executable jar. You haven't been able to see Flyway, unfortunately. 3 minutes left, so you will not be able to see Flyway unless we use something on the break, and I don't think we should. And I would like to thank my good friend Peter Koffler from Vienna, who has been a sounding board in this case. And if you're interested, these are the resources that I have been using. I'm still Thomas, and thank you for listening. If you have any questions, please ask them later afterwards. No questions?